Okay, leveling up, leveling up. So now we have x squared instead of just x, right? We have basically more than one x. We have one x to the power of 2, but we still need to solve for it. So this is a very common scenario in the kind of straightforward quadratic equation type of question, where you're given your quadratic equation. Quadratic just means that you have, an x squared, and you're told that find possible values of x when y equals 0. So let's just set up the equation first, right? Let's just rewrite this as x squared plus 3x plus 2 equal to 0, right? Y is 0. This is equal to 0. So how can we approach this? You can try to mess around with this and try to isolate x in the ways that we have done before, and it's gonna be nearly impossible. So don't even try to mess with that. If you try to subtract 2 and then subtract 3x, but there's no really way to isolate the x using the sort of skill set we've done in the linear part. So what can we do? Well, basically we have two options. They achieve the same kind of result, but they're just kind of different in their approach, and so you can pick whichever one you're more comfortable with. We're going to start with something called factoring. So when you're looking at something like this, what is factoring? Factoring is when your coefficient of your x squared is 1, so when you don't have a number here, right? All you have to do is you have to find a combination of numbers, or rather two numbers, that will add to the middle number and multiply to the last number. So in this case, for example, I'm thinking, okay, something that adds to 3 but multiplies to positive 2. Well, 2 and 1 work, right? So 2 and 1 add to get 3, but they multiply together to get 2. So 2 and 1 are our numbers here. So once you figure that out, you've nearly solved the equation. So this is how you write it. This is how you write the factored form. Why is it called factored? Well, you're converting this into just two factors, things that you can multiply together to get this again. So we said 2 and 1, right? So you do x plus 2, close parentheses, and another one, x plus 1, still equals 0, right? So again, let me sort of explain the conversion we just did here. So we decided that 2 and 1 add to here and multiply to get that. So why do we put it in that format? Why is that significant? Well, if you try to multiply this out, you'll get your original. So again, if you just to kind of test yourself, if you did x times x, okay, that's x squared. X times 1 is just plus x. 2 times x plus 2x. You see, we need those two numbers to add to get 3x. And 2 times 1. So again, so you do the first one, you do your first sort of term here times both of them, then your second term times both of them. So where were we? Yes, 2 times 1 is our last term, which is just 2. This simplifies, combine your middle like terms here, becomes of course x squared plus 3x plus 2, which is exactly what we started with. So the point of this operation isn't to change your, it doesn't change the value of your equation or anything like that. It's just sort of reformatting it so that you can actually solve it. So now that you're here, we can actually solve it. How? Well, we're looking at this equation, it's still set equal to 0, right? So the cool part is that if you want this to be 0, you can either have either this part or this part equal to 0, and your equation will be true, right? So for example, if we have some x value that made this part 0, doesn't matter what's over here, it'd be 0 times whatever's over there, which would still be 0. Conversely, if we have some x value that makes this part equal to 0, doesn't matter what this part equals because it would be 0 times whatever's over there, so you'd still get 0. So how do you actually figure out what x values work? You set each individual factor equal to 0, right? For the reason that I just explained, because either one of them can be 0 and the equation is true. So let's set x plus 2 equal to 0 and x plus 1 equal to 0. So how do you solve it? Well, for this one you should do minus 2 on both sides, right? So for here, x can be equal to negative 2. And here, subtract 1 on both sides, you get that x is equal to negative 1. So which one of these is the solution? They both are. Both numbers work. If you want, you can plug negative 1 and negative 2 into your original equation, and you'll find that both values will make this equation equal to 0. So both of these are actually solutions. So graphically, what does this mean? So I know we're not working on graphs yet, but I again want to kind of give a little bit of context for it. So we know that our parabola, if we have some graph, when you solve this, the x values that you get are the x values of your x-intercepts. So graphically, if you got this, you would know that this parabola intersects the, oops, I totally missed that, that's my bad. Intersects the x-axis at points -2 and -1. So that's just for a little bit of context. That's what it means graphically. That's not directly what's important right now. I just kind of wanted to give an understanding. So we've solved this one. Again, got some new stuff going on. Let's move on to another example where we can sort of see some new numbers and see how it works in a different case.